Again, I apologize for the heat. Okay? It's warm in here. Warm. Yeah. Earlier today, I was over here and I was talking to my class and I was doing my lean like I normally do because this is my favorite spot to teach in this room. And then I realized I'm like, why am I sweating? And then I realized that these are on and kicking out heat right here. Good. Yeah. These are the vents. All right. So today we're going to start 4.4, which that means nothing to you because we don't give you guys a textbook, but it's section 4.4 out of the textbook, but it's graphing sine and cosine curves. So today we're going to get the basics in, and then we're going to do 2 of the 4 transformations today. We're going to do the 2 easy ones today. Tomorrow we'll do the 3rd one, and Friday we'll do the 4th one. Okay? So that's our plan for today and pretty much the rest of this week and stuff like that. Before I forget, if you're planning on doing a unit circle extra credit project, those are due the 15th of December, which is in 2 weeks and a day. Okay? So if you're going to do one, that's when they're due by. Okay. All right? Let's do this. Okay? So let's take a moment here to recap some sine and, well, really we're talking and the cosine function too. Okay. So let's recap sines and cosines. Okay. So the independent variable, that's the input that we use to put into the function. That in a trig function is an angle. Okay. We put an angle into the function. The cosine of 60 degrees. The sine of pi over 4. Okay. We put angles into the function. What we get out, the output, is a real number. So we're going to put in an angle measurement. We're going to get out a real number. Okay. Let's see what's underneath the shade. What is underneath the shade? You would think I know by now, but yeah, we're not going to talk about that. We'll talk about that in a minute. Okay? We'll talk about it here instead of there. Okay? So if we graph the sine function, or if we were graphing the cosine function, our independent variable would be our angle. So that means that if we're on an XY plane, then our inputs would be our positive angles here and our negative angles here. And our output, our dependent variable, that would be like the sine value if we were on the unit circle. It would be the vertical distance to the x-axis. Could be the graph value. Positives are going to go up. Negatives are going to go down. So then those are just going to be down. Good times. Okay. So you all have a two-sided sheet and a piece of spaghetti out in front of you right now. Okay. Okay. So at the top of the front side, it should say y equals the sine of x. On the back side, it should say y equals cosine of x. Okay. So what you have here now is you have at the bottom, you have a unit circle. Since we're graphing sine, what we're going to be measuring is we're going to be measuring the vertical distance to an angle measure. Okay? Now, these angles on this unit circle are in 15-degree increments. Okay? So what we're going to do is, or what I shouldn't say what we're going to do, because it's hard for me to do it here on the board. Very easy for you to do it with spaghetti. Okay? So what you're going to do is you're going to measure out, let's say, 15 degrees. And that measurement is going to be right there. Okay? Then you're going to go up here to your graph, and you're going to find 15 degrees. Okay? And that's where you're going to put a dot. Whoa, where did that go? And you're going to put a dot right there. So right here is my 15-degree dot. The boxes are in the same unit. You're going to measure with your spaghetti. You can break off chunks. Okay? You look confused. Okay? So what you're going to do is you're going to go back down here to your unit circle. Okay?
Yeah, why did you
Because that's how much I measured. Okay? Right? So you're going to measure this distance with your spaghetti and then break off that chunk. Okay? Then you're going to measure this distance with your spaghetti, break off that chunk. And you're going to go all the way around the circle. And you're going to create your sine graph. Okay? Right? Everybody else clear? You can either break off chunks or you can mark on the spaghetti. Yeah. Exactly. All right, so to save time, there, and there. You should have a first flap that looks like that. Yes? Okay. So, a couple of things about the sine. That's the first flap. We call that the first flap of the sine, or first flap sine wave, or sine curve. Now, the thing is that this curve continues on and on and on and on because you would just keep going around you would just keep going around with your angles. Okay? And so it would keep waving like that all the way through. Okay? Love it. Now, what I want you to do is flip over, and now you're going to do the cosine. But now what on the unit circle, so again, down here at the bottom, we gave you another unit circle. So for sine, you measured vertically off of the horizontal axis. For cosine, what are you going to measure? Horizontal, because cosine is x. So now, for 15 degrees, oops, that's 150. So now, for 15 degrees, you have to measure that distance. But, here's the big but. Okay? Here's the big but. When you go to put it, so that's 1, 2, 3, 4, a little bit less than 5 blocks. When I go to put it on here, now, 1, 2, 3, 4, a little less than 5 blocks. That's where it would go. I put it on the graph vertically. Measure horizontally off the unit circle. Put it on the graph vertically. Okay? Again, whole lap. Okay, so you should have a graph, because the distances should all be the same. You should have a graph that looks like that. Okay? So again, we would call this the first lap cosine curve. Okay? Missed it. Must be a goal. Okay? So, I have a picture. I'm going to come back to my picture, but now we're on the sine side. Okay, we're on the sine side first. Okay, I'll come back to it, but I want to talk about all of these observations that we have for the sine curve. So on the bottom, in the bottom corner of your, right on your sine curve side, put down these observations. First observation is the domain of our sine curve. Is there any values of angles that I can't put into the function? Is there any angle that I can't put into the function? Like, did you find a spot where you were dividing by 0? No, right? So all angles can be put in, so that means that my domain is all real numbers. Okay? And that will be for all sine curves, all cosine curves, your domain is always going to be all real numbers. Okay? Because there's not a value that you can't put in. Next observation, you tell me this one. On your curve, what is the maximum value of the sine curve? 1. It tops out at 1. What is the minimum value? -1. So since it tops out at 1, bottoms out at -1, that is my range. It will never go outside of those values. Which you already knew that, because you already knew from the unit circle observations that sign had to be between -1 and positive. Okay? So if -1 is my bottom and +1 is my top, what's the middle then? 0. 0. Next up, we have this thing called amplitude. Okay? And the amplitude is the distance from the middle to the top, not to the tor, to the top or the bottom. Okay? I'm going to go back up to my graph here now. We'll come right back to this. Okay? First off, I'm going to put a couple of lines on here. Okay? So this is my top, my middle, and my bottom, or my low, I should say. We should both tap the brakes lines. Get it in the right terminology. Low and high. Okay? So the amplitude is the distance from here to here, or from here to there. Okay? That's what we mean by the distance for the amplitude. So in this particular case, the distance from 0 to 1, or from 0 to -1, is 1. Now, for all of the graphs that you have coming up in the next week and a day, we're going to ask you to give us, if not all, some of these, okay, for each graph. Okay? So that's all the vertical stuff. Now we start with the horizontal stuff. So the start here is the horizontal start to the first lap. Okay? Meaning we started at 0 degrees or 0 radians. We ended, if we think about we're walking up and down some hills. Okay? So I'm walking up a hill, then I come walking back down a hill. Now I'm back at the starting height, but I'm not in the same position because I'm walking down the hill. I need to be walking back up the hill at the same position. So here is my start. Here is my end because I'm walking back up the hill again, which would put my end at 2 pi. Now the period of the function is the horizontal distance to complete one wave or one lap. We can easily find the period by taking our end angle and subtracting off our start angle. So the period is always end minus start. In this particular case, the period would be 2 pi. All of your graphs today, your period is going to be 2 pi. Tomorrow, we'll deal with some period changes, and then your periods won't necessarily be 2 pi. Okay? Questions on any of those? I think that's 9. Is that 9? 3, 7, 9. Yep. So find me now the same 9 observations, but flip your page over and give it to me on the cosine side. Inclusive? We'll work our way up. Mom. Great. Command is all real numbers. Love it. Working our way up still. Anybody in this general area? Any of them that we have left? High is 1. Love it. Low. Middle.
0.
Oh, we'll just do it this way. I like this better. Amplitude.
1.
Love it. Start.
0.
End.
5.
Period. 2 pi. Love it. Love it. All right. So, what we're going to talk about then is we're going to talk about these. We're going to talk about these in the next week. Might even longer than that. Well, basically the next week and 2 weeks in a day. Okay? Those are the, for lack of a better term, the parent functions for sine and for cosine. Okay? We're going to deal with today, we're going to deal with A. Okay? And we're going to deal with D today. Okay? So A is going to be our amplitude. That means that it is going to stretch vertically. D is going to be our vertical shift. So we're going to take our middle, and we're going to move the middle up and down. And then everything else is going to adjust off of that. Okay? Now, in the next coming weeks, we are only going to ask you to draw for us the first wave of the graph, or the first lap of it. So one more observation for you is that when you have a cosine graph starts at the high point, then it comes to the middle, then it goes to the low point, back to the middle, and then ends where it started, up at the high point. The sine curve starts in the middle, goes to the high point, back to the middle, then down low. Oops, almost put high, and then back, ends in the middle. Okay? Those two patterns will be for every single one. We might make adjustments of it, depending. It might go higher if we have a bigger A. It might go lower if we have a bigger A. But it will always follow that path. Unless we have a negative A. We'll get to that. Okay. So that's what we're going to graph. We're going to be graphing all of these. The first wave. First wave. Good? Let's do this. Oh, my Lanta, one of these days I'm going to remember to fix this. Go. So let's talk about for amplitude. Okay? So first off, the amplitude is always positive because it's a distance. Distance from middle to high, middle to low. Okay? So what the A controls it controls how high your curve goes. It controls how low your curve goes. Which then also is the range. So that's what the A value controls. What it also does is it flips the graph. Meaning, if you have a positive A value, cosine is going to look like that. We just graphed a couple. Sine is going to look like that. Okay? We just have you got those on your spaghetti wrench. But what I'm saying here is, if we've got a negative A value, then my cosine graph is going to look like a hump instead of a pothole. My sine graph we're going to do the easy part of the walk first. We're going to walk downhill. That's another big thing. All right, let's do it. Let's do one. Love it. So, in your notes now, okay, right now, you can draw yourself this kind of elongated to the right graph, but later on, even later on this week, you're just going to draw your graph first, then you're going to So first off, we got to look at some things. Okay? The first thing that we got to look at is we're dealing with a sine function. Okay? What's the domain of our sine functions? All real numbers. So we can fill that one in right off the start because all of these are going to be all real numbers. The amplitude is the coefficient on the sine function. So my amplitude in this case is 2. The middle, we talked a little bit about the middle before. The middle is what comes after the trig function. Anything? Anything after it? No, so that's 0. So now I have where my middle is. If my amplitude is 2, that means I'm going to go up 2. So my high value would be at 2. I'm going to go down 2. That means my low value is at -2. So that tells me my range is that. Horizontally, we're going to start all of them today at 0. Actually, we're going to start all of them today and tomorrow, Thursday, at 0. We're going to end at 2 pi later for today. Tomorrow that'll change, which means our period is 2 pi. Now that we've got all of our information, let's put our graph on. Starts in the middle, up, down, ends in the middle. The kicker here is, and I kind of glossed over it a little bit, we need to label our axes horizontally and vertically. Okay? So on all of our graphs, we're going to need to put in 8 pieces of, or 8 numbers, I should say. Okay? 3 of them are going to go vertically. You're going to want to put the high, the middle, and the low. Horizontally, you're going to want to put the start and the end. On there. Then you got 3 more to go. So you're going to go the halfway point, the halfway point, and the halfway point. Half, half, and half. And that's your pieces of 8 that you need to label on all of your graphs. Okay. When it comes to the test in a week and a day, I'll tell you right now that the vertical ones are worth a point, the horizontal ones are worth a point, and the shape of the graph is worth a point. So this would be a 3-point graph. We are a radian type of class. Yep. Yep. So yes, it does matter. All right. Let's do a couple more. This one I'm gonna do limited talking. You're gonna tell me what's what. What's what in the trig. All right, give me something. What do we know? Give me the easy one. Okay, that works for me. Not the easy one, but I'll take it. What do you got? Range or domain? Domain. Domain is all real numbers. Yes. I'm scared there for a minute. I understand. Something else? Start is 0. Something else? End is 2 pi, which means my period would be 2 pi. Middle is 0 because there's nothing after the trig thing or the trig function. The middle is 0. So if my middle is 0 and my amplitude is 3, right? Love it. Now, here's the kicker. Of course, they would call right now. That's going to voicemail. Because the amplitude is negative, normally, if the amplitude was positive, cosine would start up top. Middle, low, middle, end up top. But because my amplitude is negative, where am I going to start? Bottom, and then work my way up to work my way back down. So we're going to start down here. Up, down. Fill in my values. Fill in my values. Yes. Well. Try that. Yeah, domain of all real numbers. I get a middle of 0, an amplitude of 1/2, which puts my high at 1/2, my low at negative 1/2, which gives me a range of negative 1/2 to positive 1/2. Starting at 0, ending at 2 pi, which gives me a period. Cosine with a positive Now, one thing that I would recommend is that your curves are all the same size. You know what I'm saying? Like, make your curve always be the same size on your paper. And just adjust the 8 numbers on the axis. Okay? Right? Because then you just get used to drawing that curve in at the same size. You're not trying to squeeze it in and trying to make it be all, all kinds of goofy. Yeah. Yeah. It's a pretty cool idea, man. Yes? Love. Yeah. So now, let's throw a monkey wrench in the whole thing, and let's talk about a D value. The only thing that the D value does is it moves the middle. Okay? So we're going to shift the middle either up or down, depending depending on what that d value is. Okay? This works for cosine too. Okay? Let me show you what I mean by this. We're just going to dive right into the pool. Okay? So here is what it looks like. You already have it written down. You already got it written down. Yeah, that's what. Okay? Okay? So this first one right here, this is how we like to write it. Okay? Right? Because it's in that form that we have. Okay? We found in the last 5 years, this is how the tech likes to write it on the final. Okay? They mean the exact same thing. Okay? They just put their number first and their trig function last. We like to put our trig function first because we're all about trig. Okay? Okay? But they mean the same thing. Okay? So this right here, this is my d value, or conversely over here, that would be my d value, which is the only thing that d value controls is the middle. Right? So the middle now is 10. Okay? Everything else we do the same way. So the number in front, the coefficient of the trig function, that's my amplitude. So my amplitude in this case is 1. Which means if my middle is at 10 and I go up 1, what's the high value? 11. If my middle is at 10 and I go down 1, what's my low? 9. So my range now is from 9 to 11. Okay. Domain is still all real numbers. I'm still starting at 0. I'm still ending at 2 pi, which means my period is 2 pi. Now, here's where you need to tap the brakes a little bit. Okay? So this is one of those cases where I would draw it in first, and then I would adjust my axes accordingly. Okay. So now here, this is 9, halfway is 10, top is 11, 0, I, and there we've got the graph. Okay. So again, put the curve on first, then put the axes on the top after you figured out where it's supposed to be. Okay? Questions on that? Oh my gosh. You guys are the best. I mean, we're 10 minutes ahead of schedule already. Love it. Okay? All right? You guys try this one now. Graphing this one. Yeah. All right. Domain. I got all real numbers. Yes? Love it. Middle. I got -2. Amplitude. I got 4. Which would put my high at +2 and it would put my low at -6. Start end period. 0, 2 pi, 2 pi. Any questions on that? Oh, I forgot the, I did the range. -6 to 2. I didn't do it because I just literally forgot about it. Nope. That was my only reason. Okay? Okay? So, this is a sine curve, correct? So that means we're going to start in the middle, up, down, middle. Halfway. Cool. Okay. Good there. But now my horizontal, my x-axis is going to come up actually. And wait, no, middle is -2. Pi is 2, so we're about in there halfway. Yep. Yep. So now this down here would be -6. This would be -2. This would be +2. This would be 0. Pi over 2. Pi. 3 pi over 2. And yes, sir.
Do you need a line, like, since this is -2, do you need a line at -2 or across?
That's up to you. If you do that, I would make it be dashed. So like if you're saying if you wanted to do this, yeah, I would make it be dashed, if you will, because then it's not part of your axis. Yeah. Good stuff. Great stuff. Not a lot of money. Festival food soon to be in. Yeah, the bottle trick.